All right, here we go. Second part of section 10.3. We're going to be talking about perpendicular bisector of a chord. If a diameter of a circle is perpendicular, so I'm reading this right here, to a chord, then it bisects the chord and its arc. So if I zoom in here, what we can do is we can mark this, we can mark those two congruent, and there we go. Okay. And then we have our right angle there. What we're going to see here is the converse. The perpendicular bisector of a chord is a diameter of the radius. So if it is congruent already, then we know that this is the diameter or the radius. Okay, a couple examples. These got deleted out of this when I uploaded it for some reason. So it says in circle S, PQR is 98. So this arc right here is 98. Find PQ and PR. I'm going to undo that, and I'm going to highlight it. And then I'm going to write my 98 up here. All right, I'm going to zoom in a bit. I know that these two are congruent because this forms a right angle perpendicular bisector. So all I do is I take half of 98, okay? So I know that the measure of PQ is 49. And then it says to find PR. Well, I know that because these two are congruent, perpendicular bisector, PT is 6, and then I do 6 plus 6, and I get 12. Okay, so that's the most basic problem we're going to see. Let's try another one. Next slide. Okay, this one says if in circle Y, the radius is 34, and AB equals 60. Find AD, YD, and DC. Okay. So what I'm going to do here is I am going to draw a radius here. Nice straight line. Kind of a radius. Radius enough. Okay. I also know that AD and DB are congruent, perpendicular bisector. Going to zoom in. So I know those are congruent. I'll erase my congruent mark here so it doesn't get in the way. AB is 34. So I know that half of that, this is 17. And I know this is, I'm sorry. Let's look at the numbers again, just so we know. Radius is 34, AB is 60. Okay, sorry. AD is going to be 30, 60 divided by 2. And the radius is 34. So, I found AD. Did we find AD? Yes. AD is 30. And we need to find YD and DC. So our next step is to find YD. So what I have here now, I have a right triangle. We'll call this X. We're going to do Pythagorean theorem. And actually, this is a Pythagorean triple. So I'm not going to take my time and do all the work here. But x squared plus 30 squared equals 34 squared. And what we'll see, this is it's an 8, 15, 17 perfect right triangle, a Pythagorean triple. So x will equal, so that's an 8, 15, 17. 8 times 2, 16. X will equal 16. And if you guys want to do Pythagorean theorem, you can. I'm not going to bother doing it right now. That's 16. So YD equals 16. And then I'm trying to also find DC. So that's part of the radius, right? So I'm going to do 34 minus 16, and this will equal 18. So DC is 18. We'll zoom out. DC is 18. YD is 16. AD is 30. All right, feel free to rewind and go through that again if I'm going too fast. All right, next slide here. I think I have 2 more slides. In circle R, find TV. Okay, so here's how we find TV. We're trying to find this line right there. We're trying to find TV. All right, once again, I'm going to zoom in just to make it easier to draw. Okay, I can look at this line here, my radius, and I can see it's 5 and 6. 5 plus 6 is 11. What I'm going to do, once again, is make my right triangle. 5 plus 6 is 11. Now I have my right triangle, and this part is x. So this is not a Pythagorean triple. We're going to get a decimal here for TS. So let me just outline my triangle I'm trying to find here. Right triangle. Zoom out so I have a place to show my work. X squared plus 6 squared equals 11 squared. X squared plus 36 equals 121. Subtract from both sides, do Pythagorean theorem. X squared equals, I'm going to whip out my calculator here and do 121 minus 36 equals 85. I'm going to find a decimal for that, and I am going to find that it is 9.2. So x is 9.2. In order to find the whole thing, so now I'm going to erase that. X is 9.2. And now I know that both of these are 9.2. Right? Those are congruent. I add them together, and I get TV equals 18.4. So basically, once again, I'm going to make a right triangle. I'm going to use Pythagorean theorem. I'm going to find my answer. All right. We have one more slide here. We're going to find the radius. Okay? It says that CD is 24, AF is 5. So it's going to be a right triangle once again. Let me look at those numbers. CD is 24. So if CD is 24, I divide that by 2. That means this one right here is 12, because that whole thing was, this whole thing was 24. Then AF is 5, I believe. Let me go back and look. Yes, AF is 5. And now I need to find the radius, which is right here. If I can draw right, it is right there. If you guys know your Pythagorean triples, this is another Pythagorean triple. We have, we'll call the radius r, just for fun here. R squared plus, nope, undo. Five squared plus 12 squared equals r squared. call it C if you want to, prefer Pythagorean theorem. R will equal 13. And you might say, Mr. Wilson, how did you get that so fast? It's a Pythagorean triple, a 5, 12, 13 right triangle. Just to prove it to you, 25 plus 144 equals R squared. That's 169. Square root both sides. R equals 13. All right, that is it for the second part of Chapter 10. If you have any questions, please email myself or Mrs. Belke, and we'd love to help you out. Hope you guys have a great day.